Equilibrium is covered in Chapter 19. It's a short unit for us in first year chemistry, but it's an important foundation for many topics that students taking AP chemistry will study next year or the following year. Equilibrium is a condition where the forward rate of reaction is equal to the reverse rate of reaction, and there's no net change in the amount of reactants or products. It doesn't mean that there are the same amount of reactants and products. It just means that the ratio of reactants to products stays the same. There are many things in conditions of a reaction that can affect the equilibrium position. What Le Chatelier's principle states is that if a stress is placed on a system, it will cause the reaction to shift and reestablish equilibrium. In general, anytime we add stuff to one side of a reaction, the reaction tends to shift to the other side to reestablish equilibrium. Or if stuff is removed from one side of a reaction, the reaction tends to shift toward that side to replace what was lost and come back to equilibrium. So here in number 93, it's asking what would happen to this reaction if some carbon dioxide was added to this reaction. So if we look at the reaction, the carbon dioxide is here on the right hand side. So if we add some more stuff to the right side, then the reaction is going to tend to want to shift to the left to reestablish equilibrium. Or for C, the stuff that's being removed is some carbon monoxide. Carbon monoxide is here on the left-hand side, so if we remove some carbon monoxide, the reaction again is going to want to shift to the left to replace what was lost. In number 94, the change, or at least one of the changes that they're introducing here, is a change in pressure. So if pressure is added here in A, what we have to do is look at the amounts of gas on each side. Here we have 2 moles of carbon monoxide gas and 1 mole of of oxygen gas. And on the right side we have 2 moles of carbon dioxide gas. So since we have a total of 3 moles of carbon monoxide and oxygen gas on the left and only 2 moles of gas on the right, if we add some pressure, it's going to want to shift to the side that has less moles of gas, and that means it's going to shift to the right. Another thing that can be done to change equilibrium is changing the amount of heat. So as we look at the reaction in number 95, we have some reactants and some products, and one of the products that's given off is some heat. Here we have 113 kilojoules of heat that's also produced by this reaction. So in C, when they're asking about some things that can be done to shift the reaction to the left, if we increase the amount of heat on the right side, if we add stuff to the right side, it'll cause it to shift to the left.